All right, let's rewind into some theorem work. To me, this is definitely a must review FRQ, number 2007, from the AB exam, number 3. It just has a lot of fundamentals in here that I, especially as a teacher, love to go through this one. So let's walk through this one and see what's going on. All right, they're telling me that f and g are differentiable for all real numbers. And there's probably a reason why they're telling me g is strictly increasing, but we'll see. And then we get values for f prime, g, and g prime for given values of x. And they're letting me know that some function h is a composition of f of g of x down 6. All right, so here we go. Explain why there must be a value for r, or value r between 1 and 3 such that h of r is equal to -5. Now, when I don't see derivatives on there must be a value question, I know it's going to be the intermediate value theorem. And hopefully you have some background, but we'll walk this one through. So what you want to do is you want to find the h of 1 and the h of 3. So you want to find the endpoints. And I'm going to show you why you want to do that in a second. And there's some fundamentals to IVT, or the intermediate value theorem, that we need to work out. So h of 1 would be f of g of 1 minus 6. And again, I'm just kind of making sure I get these right. So g of 1 is 2, so that'd be f of 2 minus 6. I don't want to make a mistake here. And it would kind of show itself if you did anyway, but let's just walk through this. F of 2 is 9, so 9 minus 6 is 3. Let me write that in a little deeper, or a little bolder. All right, let's do the right endpoint now for h. So h of 3 would be f of g of 3, and again, I don't want to mess these values up, minus 6. So that would give me g of 3 is 4, so f of 4 minus 6, which would give me -1 minus 6, which is equal to -7. Coming off a little bit, but that's okay. All right, so I found h of 1, h of 3. And if you notice, my range values from the left end to the right end span from bottom -7 to top 3. So if f and g are continuous, then that means h is continuous. That's just the way it works. And there's a theorem that you should have learned where you take the composition of two continuous functions that are both continuous, then the composition itself is also continuous. And you don't need to state any of this. So let's kind of work our way through how to do this. All right. Now, they only told me f and g are differentiable. That means that we know they're continuous, right? I would just probably use that statement and say f and g are differentiable. Therefore, and I'm going to take a leap, f and g are continuous, right? F and g are in a composition for h, so therefore h is continuous. You got to state that. So for the intermediate value theorem, you want to state continuity, all right? They could do it with a piecewise. You'd have to show continuity at any splits, anything like that. Now here's what I would write. I would then say, I would go left to right. So my lowest value is at h of 3. So I would let them know, and I always set up a compound inequality when it comes to the intermediate value theorem. I would say h of 3 is negative 7, which is less than h of r, which is equal to negative 5. This is how I do it. I always formalize this stuff with my students just because this should be some easy points if you understand it and you've applied these enough, which would then be less than what h is at the left endpoint of that interval. So h of 1 was 3. So what we did show was that at the right endpoint, the range is negative 7. At the left, it's 3. And the whole idea is that it's going to span all those range values to get from top to bottom, in this case, from left to right, in the range, because it's continuous. And that's it. So, and let's use their words. There must be a value r for r between 1 and 3 such that h, I apologize on that, such that h of r equals negative 5 by the intermediate value theorem. You have to state that. You don't have to state what the theorem is because you've formalized it in your work or in your explanation. I think my penmanship needs to get a little better, and hopefully it will as we go. Check the endpoints, get those range values, then state continuity, set up a compound inequality going from left to right in your range. So I had to flip my 3 and my 1 to go from left to right in my, or I'm sorry, bottom to top in my range, right? Went right to left in my domain in this case. And then just use their words to answer it, and then by the intermediate value theorem. Don't over explain it. Try to find some more of these type of problems and practice it exactly like that. All right, next one. Explain why there must be a value c between 1 and 3 such that the derivative of h at some value c is equal to negative 5. The moment I start seeing first or second derivatives where they ask me to explain why there must be a value, I know it's the mean value theorem. And I'm going to show you another one in this playlist because I think you definitely need to know how to do the mean value theorem. And again, it boils down to, now mean value theorem boils down to the slope of the secant line. So using the endpoints on the closed interval, so that slope of the secant line on the closed interval, if it's continuous and differentiable on the interior of that domain, then there has to be a slope of a tangent line that equals the slope of that secant line. And again, hopefully that was taught to you properly. But here's how I would talk with mean value theorem. Mean value theorem, you got to take it one step further than the IVT. You not only have to talk about continuity, you also have to talk about differentiability. So f and g, use their words again, are differentiable. Therefore, and it goes back to the theorem stating that two differentiable or two continuous functions where you take the composition of the two would also be differentiable and continuous. So you don't have to state that. So you'd say, therefore, h is continuous and differentiable. So that's the first piece of explaining the mean value theorem. Talk continuous on the closed interval, differentiable on the open, but we don't have to go that deep. All right. I like to just state next what the slope of the secant line is. So the slope of the secant line, I hope you know what that is. For h on the closed interval from 1 to 3 is, now I'm not going to skip any steps here, h of 3 minus h of 1 all over 3 minus 1, which is 2. Now, there was a reason why we figured that out up here in part A. We already did it. Remember, h of 3 is -7 minus h of 1, which is 3, all over 2. So -10 over 2 is -5. Comma. Now start using their words. So we just showed the slope of the secant line's the same as the slope of the tangent line on the interior, right, of the intervals. Use their words. So there must be a value C for C between 1 and 3. So on the open interval, such that h prime of C equals -5 by the mean value theorem. I feel like my handwriting is a little more sloppy than usual today, but oh well. I have bad hands. That's why I write so hard. All right, so there's the mean value theorem. Make sure you state continuity and differentiability. It has to be continuity on the closed interval, differentiability on the open interval. Once you state that, find the slope of the secant line. Make sure that matches up with what they're trying to get you to figure out, and it always should. And then just use their words and state by the mean value theorem. Hopefully that helped. All right. Let w be the function given by the integral from 1 to g of x of f of t dt. Find the value of w prime of 3. This is FTC part 2, where you're taking a derivative of an integral. In theory, it should cancel out, but let's talk order of operations. So let's just write what w prime of x would be. Now remember, order of operations would tell us to integrate this first. So we would integrate f of t, use FTC, plug in g of x, subtract plugging in 1, and then come back and take a derivative. So that means the chain rule comes into effect. So when I come back and take a derivative, after I plug g of x into FTC, the first part, I would have to chain out on the backside a g prime of x. And then the integral and the derivative would cancel out, but I'd be plugging g of x into f. But remember, when you integrated, the second part of FTC is subtracting plugging in 1. But when I get a constant and I come back and take a derivative, the derivative of that would be 0. I don't know how you learned FTC part 2. Some students struggle with that. Hopefully that helped you a little bit. W prime of 3 would equal g prime of 3 times f of g of 3. So let's carefully do this. G prime of 3 is 2. G of 3 is 4, but f of 4 is -1. 2 times -1 is a -2. All right, so that was FTC part 2. IVT, MVT, FTC part 2. Now, the reason I love this problem is because now we can even talk about the shortcut for taking the derivative of an inverse of a function. All right. If g inverse is the inverse function of g, write an equation for the line tangent to the graph of the inverse of g at x is equal to 2. All right, this is how I teach it to my students. We have the g and we have the g inverse. And what I always teach this rule to after, like, you need implicit differentiation to show you a few times, like, oh, this is what's happening when I swap the x and y, right? It might become a relation. Use implicit differentiation, solve for the dy dx, right, of the inverse, and you can see the relationship between the function itself and its inverse when you take the derivative. Again, hopefully you figured that out. All right, I'm going to call this, I always have my students write OP, and that means the original point, because I always think you should organize the points, right? Because an inverse means you're swapping the x and the y's. That's the mapping of it. So the inverse point, or the point that would be on the inverse, is here. Now the problem's designed for me to make the x coordinate to the x coordinate of the inverse, which means that's the y coordinate of the original point. That's the relationship. So if I go back up into g and I find the output value at 2 as an x value of 1. So then the x value of the original point would become the y value of the inverse point. And then you should know the shortcut is if you take the derivative with respect to x of the inverse at 2, you would get 1 all over the original function, g prime, at 1, or g prime of g of 2, but I just always say just use the y value of the inverse point when you plug it in there. 1 over g prime of 1 is 5. I have my slope. I have my point on the inverse, so I can set up my tangent, and I'll just write a sentence for this. So the equation for the line tangent to the graph use their words, of g inverse of x at x equal 2 is, and now remember, just use point slope. Remember, we're using the inverse point, so that'd be y minus 1 equals the slope at 2 for the inverse, which is 1/5, all times parenthesis x minus 2, the x value, the inverse point. Done. One of my favorites. I think there's a lot of fundamentals in there. It has both of the theorems in here, but it doesn't have the extreme value theorem. One of the secure tests for teachers has the extreme value theorem in it. All you have to do for the extreme value theorem is show that the function itself is continuous on a closed interval. And then the extreme value theorem states there has to be an absolute max or a min on a continuous closed interval. And you would just state by the extreme value theorem. That's it. Don't overthink it. Hopefully that helped. Again, I told you, love that question. Keep going.